Hello and welcome to the presentation of designing a PID controller to control an air heater which follows a set point, and also this basic data of controller and air heater is sent to cloud in SQL Server, where another .NET application is being written to read the data from SQL Server and show it in a website in a curve form. A description of the whole application and the steps what is done while designing and implementing. First, after designing the whole system of the controller, a frequency response and the stability analysis is being done. Then the Python application is written where it reads the temperature of air heater, and it also reads the temperature of set point of controller, and then it's sent to Modbus server. From Modbus server, it is then again read and send it to SQL Server in Azure Cloud. And finally, an ASP.NET application takes this data from SQL Server and present it in a website. So that would be the overall architecture of the system. Zooming into the heating and controller part would be this diagram, where we can see that the output of air heater is not directly sent to Modbus, but it is being passed through a filter. So the data are not scattered, and after it passed through filter, it's updated in Modbus. So as it's mentioned that there are two applications, one is Python and one is .NET. So the Python application is written on thread-based program, and tkinter library is used for the UI design. This is the Python application where the all main service is running on this start main loop thread. So a while loop is running in this thread where it simulates the air heater and takes the output, and this output is passed through a filter, and then it's updated in Modbus. Then SQL connection is connected and the data is read from Modbus and send it to SQL server. Then it's disconnected. Second application, which is web-based application, is also hosted in Azure Cloud, and the web page plots a graph of temperature and set point, and Ajax is used to call the data in the background without refreshing the page. This is the CS HTML page where Ajax call is being done every 2000 millisecond, and data is added to the curve. The next part is to tune the controller. So to tune the controller, Ziegler-Nichols method is being followed, setting up the TI value to 100,000 and then varying the KP. Get stable oscillation is got for a value of 170.57. So this value is again used next to calculate the KP and KI of the system. And the stability analysis is also being done of the system, and it is found that the GM value and the gain margin and the phase margin is within the acceptable range, which proves that it's a stable system. This is the Python application that we will run first to simulate air heater and the control system. And before running this application, we should start a Modbus server, because it will update the Modbus server with the values. So if we start this application and we hit start, then we will see that these values are being updated with the temperatures and set points, and similar changes we will be able to see in web application. So if we go to our web application, and we start our service, then in the link we should be able to see the curve moving, which is updated from the SQL. So if we start monitoring the application from ASP.NET Server, we can see this curve is being monitored, and if we set the new parameter, so it's updating the set value, and it's also showing the temperature movement. We can further increase the value. So by this way, we can see that this application is running from here, and this is the web application hosted in Azure, and this is the database that is hosted in Azure. And we can stop monitoring from here. In this section, SQL injection and cybersecurity, we should take care of some parts. Like the very beginning, we should take care of the login authentication. So by no chance we should use the SA option for accessing the database server, and also we should not keep the username and a password in the code. It should be kept saved on the application settings page. And the second part in SQL Azure is to configure the IAM properly to minimize the open access for all the users, all the part of the database. So different access should have different role, and the role-based access should be different for different user. Another option to protect the database is to use the views instead of directly copying the database table model in the classes. Using HTTPS connection would be also another secure process to communicate with the server. And finally, setting up a simple firewall should be an important part to get rid of very minor disturbance, or it can also go to a major disturbance. Thank you.